It is a clear morning in Dubai Marina. The sun climbs over the Persian Gulf, and a slender white tower catches the first light along its spiraling flanks. From base to crown, the building appears to twist, as though caught in the slow motion of a dancer's turn. This is Cayan Tower, and its silhouette is not decoration. It is physics made visible. Cayan Tower rises 306 meters above the waterfront. It holds 73 floors of residences. Yet its most famous feature is not its height, but its shape. Each floor rotates 1 2/10 of a degree from the one below it, so that from top to bottom the entire structure completes a 90-degree turn. The tower opened in June of 2013 after nearly 7 years of construction. It was designed by the Chicago firm Skidmore, Owings and Merrill, the same practice behind the Burj Khalifa. The lead architect was Marshall Strabala, working with structural engineer William Baker. Together they set themselves a puzzle. Could a skyscraper twist 90 degrees and still stand against the desert wind? To understand the answer, one must first understand the wind. In the Persian Gulf, the shamal blows in from the northwest, driving hot air across the sea. Tall buildings interrupt this flow. As wind meets a straight-sided tower, it curls into vortices behind the structure, shedding first from one side, then the other, in a rhythmic pulse. Engineers call this phenomenon vortex shedding. It creates a sideways force that can make a skyscraper sway alarmingly, even in moderate gusts. In the worst cases, the shedding frequency matches the building's own natural vibration, and the tower begins to resonate. This is the same physics that felled the Tacoma Narrows Bridge in 1940. For tall buildings, it is the enemy that must be tamed. The traditional solution is mass. Engineers add stiffness, thicken columns, and install enormous tuned mass dampers near the top. Taipei 101 famously carries a steel sphere weighing 660 tons, suspended like a pendulum to counter the sway. But Cayan Tower takes a different path. It defeats the wind not by resisting it, but by confusing it. Because every floor turns slightly relative to its neighbor, the tower presents no consistent flat face to the wind. Vortices cannot organize into a coherent rhythm. They form, break apart, and reform at different elevations, cancelling one another before they can build into resonance. The twist scatters the wind's grip along the height of the building. Wind tunnel tests at the Rowan Williams Davies and Irwin Laboratory in Ontario confirmed the effect. Models of Cayan Tower were placed in scaled boundary layers, and pressure sensors traced the flow. The results showed a marked reduction in crosswind forces compared with a conventional rectangular tower of the same height. The shape itself was doing the work of a damper, but a twisting geometry brings its own difficulties. Every floor plate must sit in a slightly different orientation. Every window, every balcony, every exterior panel must be cut and fitted at a unique angle. And the vertical load path, the invisible column of gravity that carries each floor down to the foundation, must find a way through a form that is constantly rotating. The solution lay in a central concrete core. Inside Cayan Tower, a stiff cylindrical spine runs the full height of the building, unmoving and straight. Elevators, staircases, and services thread through it. Around this core, the floor plates rotate outward, cantilevering from the fixed center like leaves fanning from a stem. The twist is skin deep. The heart is upright. The core is made of high-strength, reinforced concrete, poured in a continuous slip-form operation. Around it, the perimeter columns follow the twist, tilting slightly at each floor to trace the spiraling facade. These columns carry gravity, but also transmit lateral forces back to the core. The result is a structural system called a core and outrigger frame, common to tall towers but adapted here to a geometry no one had built before at this scale. Then there is the sun. Dubai lies at 25 degrees north, and summer temperatures push past 45 degrees Celsius. A conventional glass tower would bake, forcing air conditioning systems to work relentlessly. But the twist of Cayan Tower shades itself. As the building rotates, upper floors cast shadows over the balconies below, blocking direct sun during the hottest hours. The facade is clad in aluminum panels finished in a reflective white. This choice reduces solar absorption, keeping surface temperatures lower and easing the cooling load. Windows are recessed behind horizontal bands, further shielded by the curling parapets of each balcony. Every architectural gesture serves a thermal purpose. The tower is dressed for the desert. Construction began in 2006 under the developer Cayan Group, initially known as Infinity Tower. Progress was slow and beset by misfortune. In 2007, a cofferdam collapse flooded the excavation from the neighboring marina, submerging early foundation work. Crews had to pump out the site, reinforce the perimeter, and start portions of the substructure again. The setback delayed the project by more than a year. Then came the global financial crisis of 2008. Dubai's property market, which had roared through the previous decade, collapsed almost overnight. Cranes across the city fell still. Cayan Tower's construction slowed, but it did not stop. The developer pressed on, and by 2013 the building was complete, one of the few major marina projects to emerge from the crisis on something close to its original vision. Inside, the twist shapes daily life. Apartments on higher floors face different compass directions than those below. A resident on the 10th floor might look east toward the desert, while a neighbor on the 60th gazes north across the Gulf. No two units share exactly the same view. The building offers, quite literally, a rotating perspective on the city. Cayan Tower was not the first twisted skyscraper. That distinction belongs to Santiago Calatrava's turning torso in Malmö, Sweden, completed in 2005. But at nearly twice the height, Cayan pushed the concept into a new structural territory. It proved that a full 90-degree rotation could be executed in reinforced concrete, in a hot climate, against strong coastal winds, and still meet the demands of habitation. Since then, twisting towers have proliferated. Shanghai Tower, completed in 2015, rotates 120 degrees over its 632 meters, and its designers cited the same aerodynamic logic. The Evolution Tower in Moscow, the Absolute Towers in Mississauga, and others followed. Cayan's contribution was to demonstrate the principle at scale and in one of the world's most punishing environments. There is a deeper lesson in the tower's geometry. For most of the modern era, engineers fought the wind with mass and stiffness. Cayan Tower suggested another path, shape as strategy. By curving through the flow, the building becomes harder for the atmosphere to grip. The old contest between structure and element gives way to a subtler negotiation. At dusk, the sun sinks into the Gulf, and the tower's white flanks flush pink, then violet, then blue. The shamal picks up over the water, curling around the spiraling form and dispersing into the night. Cayan Tower stands as it was designed to stand, twisting quietly against forces it was built to outwit. Wind, sun, and steel held in a single patient turn.